out the Fourier series. And for this we have a Dirichlet condition. We must know what is a Dirichlet condition. Dirichlet conditions. This is very important. And what is the Dirichlet condition? Any function is defined in the interval c to c plus 2 pi. And what is the function? The name of the function is f of x. And f of x should be periodic, and f of x should be single valued. Single valued mean for any function value of x, f of x should have a single value only, and it should be finite. Should have a finite value, and it should have a finite number of discontinuities. Finite number of discontinuities. So these are the conditions. And one more, that is f of x should have a finite number of maxima and minima. And what is the meaning of a maxima and what is the meaning of a minima? Maxima means the number of points at which the function has a maximum value, and the number of points at which the function has minimum value. So this is the meaning of maxima and minima. And at the last, the integral of c to c plus 2 pi f of dx, f of x dx should be finite. Mean it should have a finite value. Then in these conditions, we can find out the Fourier series which converges to fx at every point of continuity. So any point of discontinuity, the sum of the series is equal to the mean of the limits to the left limit or right limit. Left limit, as we know, that is f of x plus 0. This is actually right limit, and this is actually left limit. So this is the mean of that. So the sum of the series will be equal to this. So what are the Dirichlet condition in the interval this? F of x should be periodic, single valued, finite number of discontinuities, finite number of maxima and minima, and this integral should have a finite value. Then the Fourier series converges to every point of continuity, and at the point of discontinuity, the sum of the series is always equal to the mean of the right limit and left limit. So this is the Dirichlet condition. Now let us move further and find out the Fourier series of a discontinuous function. So we have a function f of x with the value. The value is 2 and 1. The value 2 is for the interval minus pi to 0, and the value 1 is for the interval 0 to pi. So the intervals are given to us and you just see the uppermost limit is pi and minus, the lowest limit is minus pi. The total period of the function comes out to be 2 pi. We can say that the function is also a periodic function, and it has a discontinuity at this point. Discontinuity means there is a break in the curve at this point. This is the point we have. Suppose this is x is equal to x naught. It means the curve has break at this point. So this is the meaning of discontinuity. There should be a break in the curve. So this is the horizontal xy plane, the horizontal and vertical axis. This is the curve we have, and the total curve is f of x. Or you can write that this is the curve of the function, but the curve has been separated into two parts, f1x and this is f2x. and there is a break at this point. So this is the meaning of discontinuous. Now we can find out the Fourier series of a discontinuous function. F of x is a naught upon 2, that is summation n is 1 to 20 a n cos of nx plus bn sine of nx. And you know that we can find out the values of these Euler constants a0, an, and bn. A0 is what? That is minus 1 over pi. What is the interval? The interval is minus pi to pi. The, this is f of x dx. Now the interval can be separated into two parts from minus pi to 0. The value of the function for minus pi to 0 is 2 dx and plus 0 to pi. For 0 to pi, this is 1. The value of the function is 1 dx. Now you can integrate it. This come out to be 2. You can substitute the limits of minus pi to 0. This is again with the limits 0 to pi. This is 1 upon pi. This come out to be 2, 0 plus pi plus pi. But it come out to be 3 pi, and pi can be cancelled with pi. So ultimately the value of a naught come out to be 3. Now this is the value of the first Euler constant. A naught is 3. Let us find out the second Euler constant. The second Euler constant is 1 upon pi minus pi to pi. And, this should be f of x into cos of nx dx. Now the interval again can be separated into two intervals, minus pi to 0 and 0 to pi. And you know that what is the value of minus pi to 0? You can see that in the interval minus pi to 0, the value of the function is 2 and the value of the function is 1 for the interval 0 to pi. So you can substitute the values here, and this come out to be 2 cos of nx dx. It is 1 cos of nx dx. Now you can integrate it 1 by 2, 1 by pi, 2 you can be written here. The integration of cos is sine of nx upon n, the limits minus pi to 0, and this is integration of cos is sine of nx upon n with the limits 0 to pi. And we all know that when you substitute the limits over here, this is for upper limit 0, sine 0 is 0, and for lower limit minus pi, sine all multiple of pi are 0. Similarly, for this pi, sine n pi becomes 0, and for 0, sine 0 is also 0. So ultimately the value of second Euler constant an come out to be 0. Now you can find out the value of third Euler constant, and the third Euler constant is Bn. The formula is minus 1 upon pi minus pi to pi f of x into sine of nx dx. This is 1 upon pi. You can split the interval into two parts again, minus pi to 0. The value of the function is 2 sine nx dx. And for the interval 0 to pi, this is 1. That is sine nx dx. Now you can integrate it. This come out to be integration of sine is minus cos of nx upon n within the limits minus pi to 0, and again the integration is minus cos nx over n within the limits 0 to pi. Now you can substitute the limits. Sorry, this is minus 2. When you substitute upper limit, cos 0 come out to be 1. This minus is taken over here, cos of n of minus pi. You know that cos of minus theta is always cos of theta, or cos is even function. So that is cos n pi, and the value of cos n pi is minus 1 raised to power n. This one. When you substitute pi over here, this will come out to be cos n into minus pi, but it come out to be cos of n pi. The value of cos n pi is minus 1 raised to power n. Actually, the value of cos n pi can be calculated with the help of De Moivre's theorem. I am going to explain it more. Actually, the De Moivre's theorem is cos of theta plus iota sine theta 4 raised to power n is uh, cos n theta plus iota sine of n theta. And now you can put the value of theta, and the value of theta can be used as pi cos of pi plus iota sine of pi raised to power n. This is the theorem, and name it here De Moivre's theorem. De Moivre's theorem. So this comes out to be cos n pi plus iota sine n pi, and we know that sine all multiple of pi is 0. So this value is 0. This comes out to be cos of n pi, and on this side this is cos pi minus 1, and what is the sine pi? That is always 0. So that will be minus 1 raised to power n. So this is the value of cos n pi. So by the help of De Moivre's theorem, we can calculate the value of cos n pi. Now, come over here. You can take a negative sign out. You can substitute the value of n pi here. Cos n pi is again minus 1 raised to power n. Cos 0 is 1. Here 1 over pi. And can be taken as LCM. This is a minus 2, and this is a plus 2 minus 1 raised to power n. This is minus 1 raised to power n, and this is plus 1. So 1 upon pi n can be written here. This comes out to be minus 1 raised to power n minus 1. Now, two cases will come over here, n odd and n even. When n is odd, and minus 1 raised to power odd value, that will come out to be minus 1 again. Minus 1 and minus 1 will be minus 2. So the value come out to be minus 2 over pi n. And when n is even, minus 1 raised to power even power, the minus 1 raised to power even number will always give you 1, and 1 minus 1 will be 0 always. In the case of even, it will give us 0 value, and in the case of odd, it will give us the value minus 2 over pi n. So this is the value of the third Euler constant Bn. So you can use this value in the series. This is your series. Name it as a series number 1. Always give number 1 when you start the question, or you can give number according to the need. Let us put the values of the constants f of x. The value of a naught is come out to be 3 plus summation n is 0 to infinity, and en is 0. The value of bn. The value of bn, you will see an is 0, and the value of bn is minus pi over n, minus 2 over pi n, sorry. So you can use this value here, minus 2 over pi n. This is the sine of n x, and 3 by 2 minus 2 over pi. And remember, this is the value when n are odd. So you can write down like this: n is odd, that is sine n x over n d by 2. F of x is there minus 2 upon pi. Now you can expand this summation by using the odd natural number. For n is equal to 1, you will get sine x upon 1. And next odd natural number is after 1, that is 3 sine 3x upon 3. And similarly sine 5x upon 5 and so on. So this is your required Fourier series of the given question. So in this way, you can find out the Fourier series of a discontinuous function also. Now let us proceed with the term change of interval. In the case of a change of interval, I am adding that is change of interval. Change of interval mean earlier the function uh, of which we have found the Fourier series that was of periodic, that was a periodic function with a period 2 pi. Now, now in our case the period will change to 2l. So the functions become again will be periodic function, but the period will be in terms of constant. Or you can say that the limits are L to L plus sorry the limits are either 0 to L or minus L to L. So we have two cases of which the limits can be. So you need to solve the Fourier series or find out the Fourier series according to the statement of the question. So let us proceed. Find out the Fourier series of the function x square. Find out the Fourier series of the function x square in the interval minus 2 to 2. This is the interval. According to the statement, what it come out to be. This is of period to L, and here the period become upper limit is 2 and lower limit is minus 2. The period is 4. So ultimately it can be written as 2 into 2. So what it come out to be, the value of L come out to be 2 in this case. Now one more thing, f of minus x is come out to be x square, that is same as f of x, and it means the function is even function. So when the function is even function, the Fourier series will be a naught by 2 summation n is 1 to infinity a m cos of n pi x over L. This is the new angle in the Fourier series. So always remember, in the case of even function, the Fourier series will be this one. But in case of odd function, suppose we have to do the question of odd function, or you can take the example that if the function is f of x is equal to x in the interval, the same interval I am taking, then the function is odd because f of minus x is minus x, that is minus f of x. So the function is odd because this is the statement of the odd function. So when the function is odd, the Fourier series will be fx is equal to summation bn sine of n pi x over L. N is 1 to infinity. Ultimately, what I want to say, when the function is even, we need to find these two Euler constants, a0 and an only. But when the function is odd, we need to find only p. So this is the meaning. And let us find out the first Euler constant A naught. The formula is first of all, what is L? We just we want to find out the value of L first. And the formula is 1 over L, that is minus L to L f of x dx. I am writing down the general formula, and this is the formula for A naught, and the formula for An is 1 over L minus L to L f of x into cos of n pi x over dx. These are the general formulas. General means when the limits are in the form of L. But uh, also write down the formula for Bn will be 1 over L minus L to L f of x into sine of n pi x over L dx. So let us we find out the values of these constants. A naught is 1 over L. 1 over L come out to be 1 upon 2 because L is 2 here, and that is minus 2 to 2 f of x, that is x square dx. Now, because it is even function, so when the function is even, the value of the integral, here we shall use the rule of n plus 2 class of integration, and but it come out to the integral minus a to a f of x dx will be 2 times 0 to a f of x dx when the function is even, and when the function is odd it becomes 0. This is the formula of n plus 2 class. Because the function is even here, so you will write down that is 2 times. 2 times and 1 2 is already there, so that will be 0 to 2 x square dx. This 2 will be cancelled, x cubed over 3 within the limits 0 to 2, and that will be 8 by 3. This is the value of the first Euler constant K naught. Really we can find out the value of the second Euler constant in the next sheet. In the second Euler constant is okay. We can find out the value of the second Euler constant here. Sorry, this should be an. Let's find out the value an, that is 1 over 2, that is minus 2 to f of x square cos of n pi x over 2 dx. Now, what it will be? That is an even function, and cosine is also even. So we can use this rule again. That is 2 times 0 to 2 x square into cos of n pi x upon 2. 2 will be cancelled. Now you can integrate integration by parts. First function, second function. First function as it is, integral of a second. The second one is cos. Cos integration of cos is sine n pi x over 2 divided by n pi over 2. These are limits 0 to 2. The derivative of x square is 2x sine of n pi x over 2 over 2x. So the limits 0 to 2. You can put the limit here. When you substitute 2, what it come out to be? X will be 2 here, 2 will be cancelled. Sine n pi. Sine n pi come out to be 0. And for lower limit 0, sine 0 is 0. Yeah? So it will not give any value. It will vanish. Certain value you will get that will become 2 over n pi in the numerator. So 4 over n pi 0 to 2 x sine n pi x over 2 dx. Again, integrate it by parts. First function, second function. First function x as it is. Integration of sine will be minus cos of n pi x over 2 divided by n pi over 2 in the inverse 0 to 2. Integration derivative of first function, that is 1. The integration of cos is sine is minus cos n pi x upon 2 over n pi upon 2 dx. We can substitute the limits over here. Minus 2 over n pi can be written here. This 2 over n pi. Actually, this n pi over 2 can be written in the numerator. 2 over n pi to the negative side. So when you substitute 2 here, you will write on 2. 2 here, 2 cancel, it's cos n pi. Cos n pi is minus 1 bar n. And for 0, this is 0 with 2, cos of 0 will be 0. So this is minus and minus is plus, that is 2 over n pi. The integration of cos is sine n pi x over 2 n pi over 2 with the limits 0 to 2. Now, you can substitute the limits in this integral also. When you substitute 2 here, 2 cancel. Sine n pi will give us 0 and sine 0 will be 0. Ultimately, this term will vanish and you will get the value from this component. Minus and minus will be plus 8 over n square pi square minus 1 raised to power n. So this is the value of a second variable constant Tn. Now we can find out the Fourier series by substituting the value in equation number 1. So the equation number 1, f of x is equal to T naught. T naught is 8 by 3 upon 2 plus summation Tn. 8 over n square pi square minus 1 par n. And the next term will be cos of n pi x. N pi x over 2. The value of n is 2 in this case. So you can put the values here, that is 4 by 3. So x is equal to plus 8 over pi square. Put the values when n is equal to 1. And you will get cos of pi x upon 2 divided by 1 square. And next one is for n is equal to 2. You will get that will be 2 cancel. You will get cos of pi x divided by 2 square. And the next term will be cos of 3 pi x over 2 divided by 3 square plus. So this is the Fourier series in the summation form. By this way, we can calculate the values of value constants a0, an, and can find out the required Fourier series. So I conclude here. We shall continue in the next session. Thank you very much. Any questions?